Do you know, gas leaks can cause serious incidents in homes, including explosions, fires, and injuries. If you are worried for the same, then stay with us, because we have a nice project for you. Once the gas leakage detected, you will hear loud buzzer sound and also get notification on the phone anywhere in the world. Excited? Then let's get started. Watch the full video to not miss any information. So these are the objectives that we will achieve after completing this project, so watch the video carefully. This is the brain of our project. We are using Wemos D1 Mini microcontroller for our project. This microcontroller has enough pins to connect different peripherals and sensors. Due to its compact size and Wi-Fi capability, this is best suited for our project. We are using I2C OLED screen to display gas level data on it. This is the main character of our project, MQ5 sensor. It is designed to detect gases like LPG, methane, and natural gas, making it useful in various gas leak detection systems. So let's first see wiring diagram of our project and understand how to connect them together. We are assembling the components on the breadboard. So first we will install our Wemos D1 Mini microcontroller on the breadboard as shown here. Now we will install OLED screen on the breadboard. Now it's time to install MQ5 sensor on the board. Check the pin labels carefully. The MQ5 sensor will run on 5 volt. MQ5 has potentiometer on the backside to adjust sensitivity of the gas. Also it has digital and analog pins on the module. Here in this project we will use analog pin. Now all our components installed, and we are ready to connect them using jumper wires. First we will connect OLED screen to microcontroller. Take red wire and connect VCC of the screen to 3.3 volt of the microcontroller. Take black jumper wire and connect ground of the screen to ground of the microcontroller. Now take yellow jumper wire and connect SCL of the screen to D1 pin of the microcontroller. Similarly, take blue color jumper wire and connect SDA pin of the screen to D to pin of the microcontroller. With this, our OLED screen connections are completed, and we are ready to go in next step. Our MQ5 sensor and buzzer runs on the 5 volt, so we will arrange ground and 5 volt pins on the power rail of the breadboard. Common ground wire from OLED screen given to negative line of the breadboard. Similarly, common 5 volt wire taken from microcontroller and connected to positive line of the breadboard, so our upper level power rails supplying 5 volt. Now take red color jumper wire and connect VCC of the MQ5 sensor to positive rail of the 5-volt line as shown in the video. Watch the connections carefully. And after that, take black color jumper wire and connect ground of the MQ5 sensor to negative rail of the breadboard line. As said earlier, we are using analog out pin of the MQ5 sensor, so take yellow wire and connect AO pin of the sensor to AO pin of the microcontroller. Now it's time to connect buzzer to our system. Take yellow jumper wire and connect positive pin of the buzzer to D4 pin of the microcontroller. And connect ground pin of the buzzer to common ground rail of the breadboard. And with this, all our connections are completed and we are ready to upload sketch to the microcontroller. So let's understand the sketch before uploading to the microcontroller. We are not hard-coding threshold value, Wi-Fi and pushover credential in the code. All can be done on the phone by opening Portal. So first we will need some libraries installed. For Wi-Fi capability, install ESP32 Wi-Fi library. For online Portal, install Wi-Fi Manager library. For OLED Display, install Adafruit SSD library. To store and retrieve credentials, install EEPROM library. For pushover notification, install ESP32 client library. As we seen in connection diagram, MQ5 analog pin is connected to AO pin of the microcontroller. Buzzer pin is connected to D4 pin of the microcontroller. And to access Portal, we have defined DO pin of the microcontroller. And these are the parameters that don't need to change. Here we have defined pushover notification function to send notification on the phone. Pushover is not free, but you have to pay small amount, one time for reliable and simple service. Here we are sending notification using HTTP client method. However, it is optional. Here we have created Portal, where you can set gas threshold value, Wi-Fi and pushover credentials on the phone, without connecting and uploading sketch from the PC. Read and write from EEPROM function helps to store and retrieve values from it. In the next section of the code, we have defined pins for buzzer and set up an old screen parameters. We tried to display enough information in the serial monitor, which you can see in the code and helps you to debug if any error comes. Here is the name of the access point and password to log into the portal. In this function, we will constantly monitor the state of the D0 pin. When you connect it to the ground pin, you will immediately enter into the configuration mode. Here in this section, you can see that when gas level reaches to the threshold level, the buzzers start beeping at the 500 milliseconds interval. So here is the complete sketch of our project. As you can see, we have not hard-coded threshold level, Wi-Fi credentials and pushover token and user key in the code. You can always modify them after connecting to the portal, which will save your time. So now let's connect our setup to PC and upload the sketch. If you don't know how to find COM port of the microcontroller and drivers to install, then check our previous videos. In this video we are not repeating it. So select the board from the list and select the COM port allocated to the microcontroller and hit upload button. We are fast forwarding the process. Congratulations, you have completed most of the work now, and you are almost ready. Connect the board to 5-volt power source using data cable, and first time, it will launch in the config mode. Take your phone and open Wi-Fi Manager and scan it. You will see new gas detector access point will appear on the screen. Click on it, and it will ask you to sign in to connect to the portal. The password is password in small case. Once entering in the portal, you will see Configure Wi-Fi, Info and Exit button. In the info page, you can see status of memory used. You can also erase EEPROM from the same page. Pressing Exit button will close the configuration mode and start the controller in normal mode. Let's first enter in the Configure Wi-Fi section to provide our Wi-Fi credentials, gas threshold value and pushover credentials. Select the Wi-Fi you wish to connect and provide password of the Wi-Fi. You can leave pushover token and user key fields blank if you do not wish to receive notifications on the phone. Here I am entering my token and key values for the demo. Once done, hit the save button and your work is done. Connect the data cable and provide power, and voila, your project is working now. In case, if you want to change any of the parameter we entered earlier, simply connect the 0 pin of the microcontroller to the ground pin to activate configuration mode. And now, sit back and relax and enjoy the demo. Please like, share and subscribe to our channel to encourage us to bring more exciting projects for you. I am DHK Dude, signing off.